Right, now it's time to start on this project. Now I've been meaning to do this for about a month now. I've had the board for about a month. Now these boards are courtesy of JLCPCB, so make sure you go and check those out. I'll stick a banner and advert in a second, like now. I'll stick an advert in now. There you go. This video is being sponsored by JLCPCB. You can get 10 prototype boards for only $2. Go and check them out. They are sponsoring this video and helping me to produce more content. Add your Gerber file, drag it in. By default, it's $2 for the board if it's less than 100 by 100 mil. There's my board, $2, 10 of them. Isn't that awesome? Go and see them and buy some boards. Back to this. So this is from JLCPCB and it looks absolutely fine. You know, it looks like a nice board, so the quality looks absolutely fine. This is free of charge from them, which is why the advert's in there and I keep mentioning them. So the idea here is that I build this board up and I show you what I'm doing, and this is a prototype. I have not built one yet. Okay, I've designed a PCB, but I've not actually built the circuit before. So this could be a complete and utter disaster, or it could be a miracle where it just works. And you know, I'm hoping for the miracle part, obviously. So we'll go around and we'll start populating it, and I've got most of the parts later here. The only thing I'm worried about so far is the high voltage section here and the resistor divider here, because I'm not sure I'm going to be using those yet. That part I'm not sure of, so I'm going to populate everything else. I'm even not sure I'm going to be using the op amp, so yeah, I'm not sure I'm going to be using it either. So okay, I've got this header pin here for the Arduino, which is going to go on as well. So it's just one of these things I need to sort out too. I've got this hook tip on here, which I haven't used before. It's new to me. So this is my fake Heiko. So we shall start putting stuff on. Now I think what I'll do is I'll start with this voltage regulator here. Oh, tweezers. So this is a 7805 regulator. There are better options these days. You can use, you know, like DC to DC converters and stuff. So it's an MC7805 ECD-TX. Put that to the side. Now that will just sit there, just like that. So I need to. I might even use hot air on this piece really, but we'll see how we go. Let's just try this first, see if this will work. Oh, I need to put some flux on this first, don't I? Flux. Oh, that's plenty there. Wow, that came out pretty quick. It's more than I wanted to put on. Come on. This iron tip is not agreeing with me. Wow. Yeah, this. I'm not a fan of this tip. At least not for this particular function. I'm not really doing ICs and stuff, so I might change that tip actually. This is not working for me. Alright, that's the tip changed. So we'll start again. Yeah. That's better. Much more applicable to this particular job. Now, what we'll do is get one leg on and then we'll go from there. Get it all flat on the board. And I'll solder the tab on afterwards. This would have been better with hot air than what I'm doing it, but you know, I can't bother using that. It's pretty noisy as well, so I'm trying to save you from that noise. So I kind of got this set at 300, which will probably be enough, but anyway, it's on there and on there. Now, all good. That button. So I've also got a couple of. Here's a couple of 5.1 volt Zener diodes. Now these are here as protection, input protection. So I need to find out where they go. There's one there. So let's bend this around roughly. What these are basically doing is just making sure that if something were to fail, like a resistor opened up or something like that, it would latch. Well, it'd ensure that the input to the Arduino does not exceed 5.1 volts. At least that's the plan. There's one there. I've got another one here somewhere. Where's the other one? There's one more there. So it's just as a protection. It doesn't really need them in theory unless something goes wrong. And this is a prototype. Things might go wrong. So rather than blowing up things, I'm going to put protection in. And that way, at least if I know I've got something wrong or there's an issue that happens, then it's all covered fine. Bit of flux on there. I'm going to solder from the bottom of the board, but it still travels through the board anyway. Make sure it goes through. Well, actually, you might solder a bit from the top actually. Sort of traces on the top side of this. I'll solder from the top. Let's see what happens. I should travel through anyway, but yeah, 300 is not quite hot enough for this board. I need to make it slightly better. It's now at 330 degrees, which should be slightly better. Well, that's really wonky, isn't it? That's not good. Oh, it is what it is. Okay, let's cut these off. Okay, next part. Now we've got, I'm just going to go left to right because that seems like a logical way of doing it. These are 0.1 ohm resistors, which is basically the current shunt resistor, which goes in here somewhere. I've got to find it. There we go, 0.1 ohm, right there. So that measures, it allows you to measure the current being drawn by going through the resistor. So you're measuring the voltage drop across that resistor. So that's the plan. Hopefully I've got my board layouts right. I have my helping hand thing here, my pan of ice, if I need it. Now this is a ground based feed, so it's negative that side. Part done. 10k resistors. Now these don't need to be particularly chunky resistors, so I've got, there's a 10k there, 10k there. I thought there's 3. I could be wrong. It's 100k. Maybe say 2 10ks then. Probably remembering it wrong. Okay, 2 10ks. And they don't need to be this high current things, they can be standard sizes. Just grab a couple of those. Now this one here is in the it's in series with the output, so that one there, got the high voltage output. So those two terminals, let's point to this properly, that terminal there and that terminal there, they're the test points for the device under test. Okay, so this is voltage sensing circuitry, or voltage and current sensing circuitry, and this is voltage takeoff here. So there's a voltage supply, main voltage comes in here, the high voltage, could be 500 volts. In theory it could be that high. Then you've got a dropping resistor here, and there's a 47k across here, 5 meg across there to give a voltage divider. There's that 5.1 volt Zener there to act as a clamp in case it goes over voltage for some reason, like the 47k going open circuit for example, or the 5 meg shorting out. So that should clamp it. And then from the same point here you've got a takeoff which goes to the Arduino, which gives it a voltage reference, so you can measure the voltage across the device under test in theory. And over here we have op amp here. I've got voltage options here, so if the op amp can't run if there's voltage on the board, I can inject a different voltage supply, different power supply to run the op amp in case it doesn't go rail to rail enough, that kind of thing. I'll see how it goes. I've got a couple of different op amps to use. I've marked this as a UA741P, just standard off the shelf thing, but there are better options, which I have purchased. Now, where's the other 10k go? I've lost it. There. So that 10k there is part of the voltage divider for the op amp. So it provides gain. So that's what it's for. Not that exciting, but if this project works, then I will probably release it, make it available to everyone. It's quite likely to happen. The reason I'm putting flux and I have to put the parts in is because then you've got flux on the leads of the part, which makes it easier to solder. This is for people which aren't really familiar with soldering and maybe not your best skill, or you're not really, you're learning whatever. So I'm trying to allow for that. If you're learning to solder, do not make this project, because this is probably a bit of a step up for you, because this is a high voltage project. I should actually mention that, shouldn't I? This project is based on many hundreds of volts AC and DC. So anything involving this project is done at your own risk. If you do decide to try and copy it and build it, it's done at your own risk, because this has got potential to kill you if you touch the wrong thing. Just solder both sides of the board. Really, I made these pads a bit too small. I should have looked at that when I did the design. I usually like larger pads, so you got an easier surface to solder. Alright, so anyway, that's those ones. Now, next one's 47k. Now I've got one there. I think there's only one. I think there's only one 47k, so I'll just get one of them. A bunch of random ones in the bottom. Nice. Get one of these ones out. Is that going to fit? Yes, it will. I want to use one of those old stock. Might solder. Oh no, legs are a bit short. Doesn't quite match. Here we go. Who's this one? One of those. I'd rather use the older ones and keep the matching ones the same if I can. I can let's get that bit of scrape. It's sitting in there for a little while. That's okay. Yeah, it looks right. 100k. Now, where was that? There's one there. I think there was only one. Yep. So again, she's one of these random parts at the bottom of the bin, I think. Some of these values aren't precise. I mean, like on the voltage divider stuff for the op amp, I mean, I can always, it doesn't matter if it's not exactly the right modification value. I can just tune it in the Arduino code anyway, and once I figure out what the actual voltages are, and I can just tune it and say, right, okay, it's actually this, and give divider ratios and that sort of stuff, so I can actually calculate it correctly. So I'm not overly worried by that part of it. So this op amp part I may not even use. It might be that the Arduino can read it well enough anyway without the op amp in there. So one of the things I've actually done is I've got options for different situations. So if I don't require the op amp, I can actually bypass that circuitry and just not install the chip. So I've got little things like that in there. So I'm adding all that in, and once I've actually built this, then I'll know what I need. And I may even refine the design and get another board made. I've had an offer from PCB Way as well. They've contacted me also about doing promotions, so if I need another board made, I might get it done from there and just do a comparison. Okay, that's a bit messy there. Happy with that. That's better. Right. 4.7 meg. Now again, these have been sitting around for a little while. I'm going to give it a scrape just to freshen them up a little bit. Bit of oxidization on these leads. So that's at 5 meg, which is supposed to be there. So 4.7, yeah, close enough. It means the voltage divider won't be exactly right, maybe, but I mean that's a 47. So yeah, it's close enough, isn't it? So it's dividing the voltage. It's supposed to be dividing the voltage. So that's the 4.7 megs done. Let's do this IC socket. Let's put that in next. This one I have to solder from the bottom. That should sit on there okay. I think its temperature's about right now at 330. That's working nicely. I like to use quite a high temperature and use a shorter time. I find it, it just helps it to flow in quicker and just work nicer. That's just what I prefer. I mean, some people like to use lower temperatures. Checking that side. Yeah, I can see solder on all of those legs. That's good. I can see it all. I don't know if you can see it, but okay. So that's that socket in. Now header pins. I need 3 doubles here. I need singles here. Single there, single there. So I want to do a combination of parts here. So I want some of them. This plastic sleeve has slipped up a little bit and it's a bit high. Let's just see if I can push it down a bit. Can I, can't I? Doesn't want to. Hard surface. Solder that one on. I'll get it to stay in place, that'd be good. This particular one here is for the voltage selection. So it's based on being able to set a jumper for different voltage outputs from this multiplier section here. But like I said, at the moment I don't even know if I'm going to be using that. So this board is basically, because it is a prototype, I've got all these different options built into it for what it may or may not need. So for any circumstance I should be able to use it. At least that's the theory. Can't see if it's soldered on the side, but it's all, that was all bottom based anyway. It's all traced on the bottom side. So I want single there, single there, single there, single there. So 4 of those. This is the bypass pins for the op amp, so if I'm not using an op amp, I can just leave that chip out and stick a jumper on those pins there. So again, I don't know if I'm going to be needing that yet. Is here and here. Now these are the ones for the power supply for the op amp. I think I explained this already, but if the power supply on this board isn't broad enough for the op amp to be able to do the rail to rail that I need, then I can inject my own voltage from somewhere else onto the op amp to power it. If I might have like a plus or minus 5 volt supply, for example, or 8 volt supply instead of 5 volt only. So if a single rail supply isn't good enough, then that might be okay. So we're nearly there. Now the Arduino, I have not done any software at all on it yet. There's no code written yet, so that's something I've got to do yet. So here we go. I think that one's pretty straight anyway. Better be, because I've already soldered both legs. Yeah, cool. Alright. So I think first position on that jumper is what I need. Now because this is a little bit dangerous and it's high voltage stuff, I've got to try and make sure that it is done in a safe way. Try and eliminate high voltages in various places. So red one there, another red one. Now this is just a plug to cover those up. Kind of. It's not 100%, but it's going to reduce the chance of brushing against it, I suppose. Now, because they're not popular in the other capacitors and the diodes, those other two pins won't have any voltage on them because they're fed via capacitors. If I may end up using these multiplier sections, and if I do, then I obviously have to change the setup here. But eventually, once I've decided on what I'm doing, this will be probably removed completely, and just have a jumper pin on the board. Just like a bit of wire leg from a component just looped, rather than having the header pin. Alright. Right now it's all prototype, so it's all just various options to try and figure out what we're going to do. So we've got ammeter. Well, I'm not going to bother with that just yet, so put a jumper on that. Bypass, I'm not going to do that yet. And these are op amp supply stuff, so black and oh, the red. Red's dangerous. I might do blue then. Right, you go, blue for 5 volts. That's potentially 5 volts there, potentially 5 volts there. So yeah, should be right. Yeah, that should do. Now this is it's a bypass. So if I don't put a chip in, I'll put a jumper on. Okay. Now the Arduino. This is a little bit trickier because I have to make sure it's going to line up. The thing with these headers is that they tend to rock a little bit when you put them in. Now I've broken a lot of these pins out because even though they're not actually allocated to a function, I've just brought them out so I can actually connect up to them and do various things, such as the LCD screen. Right, the intention of having the Arduino is to obviously you want to output the data and run the LCD screen. I haven't actually designed that part yet, so it should be fairly straightforward. But at the moment, I don't have that ready. So I've broken all the pins out, so I'm going to hook up to whatever pins I need, and it should be fine. I'm not going to be using these top pins now, not on the board anyway. This is just a layout which I designed for Eagle. So if I want to bring those pins out onto the board, I can do that. But in this case, I'm not using any of them on the board. So although they go to the board, apart from the ground is the only one that goes to the board there, and that's not necessary because there's 2 grounds each side here anyway. So I'm just going to shove that in there like that. Do the same thing again, hopefully get it straight too. I think with prototyping you have to try and allow for any circumstance that may happen. What do you actually need? You don't know sometimes. I'm sure there's more efficient ways you could drag solder this and that sort of thing, but so, being a double-sided board, I'm trying to get it right through the board and onto the pads on the other side. Drag soldering probably wouldn't work so well. And it's not something I've actually tried even, to be honest. I'm quite happy with this technique, it works well for me, so I am happy not to change it. Right, so there we go. That is most of the physical part of the board done. Now I've got to put capacitors in here. So I've got 10 UFs, 35 volt rated, so that should be absolutely fine. Maybe I should be using some of my chunkier ones because I've got plenty of space. Keep the small ones for something else. That's 50 volt. I think I've got some poor quality ones in here somewhere. It's unknown, 16 volt. I'd be fine in the output. I'll use that on the output. So I've got 35 volt here and a 16 volt there. Look at the difference in quality. Right, that's fine. Now, we've actually needed to have these. I didn't need one on the input really. I mean, maybe it should be a smooth supply anyway. I'm going to running the thing with, so flux again if you're getting that. So I'm not really sure it's necessary, but just for the sake of completeness, I put it on anyway. It's not really much, you know. 50-cent part. It's not really a problem, is it? But being capacitors, you don't want to get this too hot either, so I'm trying not to leave them on too long. You don't want to boil the electrolyte off. Not good. Right. So another benefit of actually using a hot temperature is that you can actually have it on there for less time. So the heat doesn't have a chance to travel right through it. If you have a lower temperature, you have to have it on there for a longer period of time, so the heat has got to travel because you've got thermal conductivity, and so it's a benefit of having a high temperature. It's one of the reasons I actually went to using high temperatures many years ago, is that you just put it on there, get that spot done, and it doesn't have time for the heat to soak right through. Now I've got over here a adjust resistor. Now that is because this is a voltage divider network, effectively, resistor network. The voltage going into the last stage can be trimmed because this is a known resistance value in total, and you've got that resistance, that voltage coming in there. So let's say I've got it stated at 550 volts max. Okay, that's what I calculated as the maximum voltage I can have on it, based on the resistor values we've got in here. If I end up having like 575 volts, for example, or 600 volts, I could put a series resistor in here, or a jumper, depending on what we have. It could be either one. And with a series resistor, I can then trim the effective resistance of this divider. So if I put resistance in here, say 10k for example, that will be adding 10k onto the overall resistance, which means the tap off point would be slightly lower voltage. So it just adds to the voltage divider section of the resistors. So it may not even need it, but I put it anyway. Again, prototype. So I shall now think about what I need to do next. Right, just a little addition to this. Now this resistor here, which I had originally designed as a 0.1 ohm, I've decided to change that because I started writing the code on the Arduino and I realised the resolution wasn't going to be anywhere near good enough. So that's the original one, it was a net 0.1. So what I've done is I've gone into a larger value. I've gone to a 1 ohm resistor, and it's also, I think it's a 2 watt resistor, I think that is. I believe it's a 2 watt, because it's going to need higher current carrying capacity as well, because of the greater voltage drop across it, so therefore it needs to have more power capability. So far the only change I've made. I may or may not use this. With a 1 ohm resistor, if I get a 5 volt drop, that's equivalent to 5 amps. which is significant. I don't see this doing 5 amps. Okay, so this is the op amp I'm going to use, an MCP6021. The reason being, this is a rail-to-rail op amp. It's got the same pinout as a UA741. It's a standardised pinout for these devices. So that's a drop-in replacement, but it does rail-to-rail. They're a bit more expensive than a UA, but it gives a broader sensitivity range on the lower end, which is quite important. And so this is configured for 10 times gain on the board here. So that means it should be able to measure quite low value, especially with that resistor change as well. If that resistor change isn't enough, I may have to increase it further or increase the gain. Depends on this low level. I need to be measuring very low currents. If it's a real problem, one of the things I've designed in here, right there, is that jumper, is if I connect, they've got those 2 pads there, as you can see, hopefully, right, just there. I can take the jumper off and connect an analog ammeter instead, and do it that way if I need really low ranges. I may even be able to do like some kind of switching, so if it's when it goes below a certain threshold, the Arduino can output a signal which will switch a relay or something and change ranges or something like that. I can do some kind of thing like that, I think. I'll have to see how that goes. Right, I'm going to show you a little trick with this. Now, this is the board. I've put a head on there, obviously, so I can plug the program into it, and I've been programming it and doing some little testing, so code's coming along, we're not there yet. So I'm going to put the headers on this board. Now, you could put male or female headers on, but I've put females on this board here. Now, these are the ones that came with this particular board. Now, this isn't the one I was going to use. This is a different variant of the Arduino board. This is a different variant of Pro Mini. I've got a few different boards. I've got a whole bunch of these, I've got loads of these, so I'm just going to use this one. This has got slightly different pinouts. It's got the A4 and A5 there, which is similar to this, but it's got the A6 and A7 down here. So they're actually in a different place. There you go, I'll make it a bit closer so you can see. Alright, so instead of being up here, they're down here. They're all slightly shorter. Just to think it is, anyway. And this programmer header here is actually flipped around 180 degrees. So you've got DTR on that side, but on this Pro Mini version, DTR is on that side. So as long as I watch out for that, I've had to make sure that I can see the markings on this board by tipping this over a little bit like that. You can see I've got the header slightly off, so I can see all the markings to make sure I don't plug it in backwards. Right, now the trick I'm going to show you is you get these little header pins, make sure they line up, stick them in the other side first. Okay, instead of sticking them on the board and then plugging it in hoping it actually all lines up, stick it in there first, put the board on there. This is how I find out how straight they are. Cool, that all drops on nicely. So that is now perfectly lined up. Can't get any better than that. Now I can just go through and solder those pins up and we're done. So that's exactly what I'm going to do. I'm not going to put any flux on this because I don't want to deal with it on the board. But so this solder here is not bad anyway. It doesn't really need that much flux. So I do tend to not use it all the time because the solder's good enough. Usually, if I've got dirty parts which have been sitting in parts for a while, putting on the other flux, this gives it a bit of an edge and helps it slightly. And again, I'm trying to get the solder right through the board. So yeah, I've been playing with the software already for this, or the firmware, when we call it, and in the Arduino IDE, and I've just got the programmer hooked up to my computer, and I've been just using the serial interface and just playing around with the various values and just trying to tune just basic software stuff to try and get an idea of if it's going to work or not, just because I have to do dividers and multipliers and things like that. So it's still very, very rough right now, but it's at a stage where it could output something if I have this connected to a circuit. It's measuring the 2 pins which it needs to measure the voltages on. That's working. Also, I don't have an LCD side set up yet, although in theory if I connect an LCD now it should actually work. I just haven't tried it. As far as how I'm going to connect an LCD, I'm not sure yet, because there's two options. I can either use a parallel display or a serial display, and I'm likely to use a serial display for the sake of simplicity, but I have the pins there to use a parallel, so I'm likely to actually just do that because I've got a few of those lying around. So that's the Arduino soldered on. So obviously now this is removable, so if this Arduino were to get damaged or blown, you can just program another one, plug it in. Right, so nice and simple. I like to use these as little modules, it's really convenient. I'm a bit of a Arduino fanboy, I suppose. I like them. Obviously there's other options. You can use PIC or even WeMOS or ESP 8266, stuff like that. You have Wi-Fi and all sorts of stuff like that. But that's not things I play around with yet. I will do eventually, but I haven't got there yet. So that's enough waffling about that. So I have installed an op-amp in there. I was sort of debating whether I needed one or not. I'm thinking about the resolution. This is a 10 times multiplier with the resistor setting there. So it's going to get whatever voltage we get here, multiply it by 10 up to a limit of 5 volts, and shove that into the Arduino, right? So that means it's effectively only got a 500 milliamp resolution across the shunt there, right? With a 1 ohm resistor, which I've got in there currently, which means when you first connect up a capacitor, especially a large one, it's actually going to go over range. It's going to go above 5 volts. So you have to draw 5 amps through it, and before that diode there kicks in to protect it. So it should not, well, it's not likely to get there, but they only shove 5 volts into the op amp at most, which is perfectly safe. So obviously the op amp being a times 10 means it's going to top out at 500 millivolts on the input. I've done that purely for the resolution on the Arduino, so it can read that resolution better, because otherwise I think it's 4.8 millivolt resolution. So by multiplying by 10, I've improved that by a factor of 10. Okay, so it's 48 millivolts resolution effectively, so it gives it much better scaling. And like I said, I may need to look at adjusting ranges or something like that as well. I may need to look at auto ranging if I don't get the resolution I need at lower ranges. So we'll see how we go. Okay, that's enough waffling. I'm going to go and play around with this some more and do some more testing, and I'll do some more recording when I've finished doing that. Alright, so I'm going to start by hooking up power to this board. I've got my cable running here to my computer so I can monitor the serial connection. And the idea then is I don't actually have to inject high voltage into it. I can inject low voltage into it and test the functionality and tune the circuitry and get it all calibrated before I even put any high voltages on it. That way I can confirm it works before I put myself at risk of electrocuting myself. Right, so no, it's never a good thing. So let's just solder these in. Now I've got the DC supply which runs the Arduino and the op amp over here. Alright, so I'm just going to hook this up, and I'll do another supply onto the DC section. So I could take that jumper there off, for instance. Oh no, I'm going to measure voltage tonight. So I could just inject I can stick it just there. It'll just give a lower scaling, because I can do up to 60 volts in my power supply here, and that should be adequate for most things. I can do that for basic testing with that, and that should give me currents. And if I need to, I can get my DC load out as well and just stick that in there and do calibration with that. Put a load across it and control the load and calibrate the readings. I'm not sure if the resolution will be low enough on that though. I'll have to have a look. So that's those. Those are going to go on there. They're going to stay there permanently. I'm not worried about soldering these in instead of using headers, because I'll just cut the wire off, then I'll hook that wire up inside the box I end up using. So I shall make this wire, I don't know, That long seems reasonable, doesn't it? So this is going to end up going to the power supply on the 5-volt rail, because I've got a triple output power supply, so it's nice and easy to do. I'll just solder these to stop them from fraying and stuff like that. Right, that'll do for those. So that's a power supply. Now I need to look at a supply for that. Now I can link across the 0 volts on there, so I actually need a positive. So normally this would be the feedback from the voltage divider circuitry. So that's like the common on the switch, or the wiper on the pot, if I use a pot, which is more likely. So that will feed back whatever the voltage divider is set to for that set voltage. So I'm looking at doing a variable voltage rather than a switch voltage, so you can do anything from 0 to whatever the maximum voltage is, and it will do anything in that range. And so that's what the multiplier and divider section here are for, to allow for that. But that is for switches. But if I just use a pot, I don't need to pop all these resistors. I can just go straight from the main supply to ground, main supply on one side, wiper goes to here, done. I don't have to mess around with all that stuff. But I wasn't quite sure what approach I was going to do at the time, so lots of things I wasn't sure about at the time when I was designing this, because I did it late at night. I think I was doing this about 2 o'clock in the morning or something like that. So in theory what I could do now is actually apply power to this, and oh, it's melted by the insulation. I bet that's a bit of a bugger. Never mind. It's only testing. If I stick a part across here, I should be able to measure its voltage values. I can measure this supply voltage here, so that'll work straight away. But I have to measure the current. In that case, I have to put something across here in order to generate a current. But that's not an issue. Let's get some leads set up and we'll do some testing. We'll see what happens. I may try and record on the computer with OBS and stream it that way, but my camera for streaming is nowhere near the same quality as this, so it won't look as good, I'm afraid. We'll see how we go. I might have a go at it. So on this project I'm going to put on a SparkFun serial LCD kit, so I've got to build the thing first. I do have some OLEDs around somewhere, I just can't find them right now, so I was actually tempted to hook one of those up, but for now I'm just going to build this and hook this up instead and see how we go.